channel where science, technology, engineering, and math are made easy. Today I'm going to be explaining how to do a simple parallel circuit. Now what is a parallel circuit? Well, a parallel circuit is a circuit where electricity has more than one path to ground, contrasted to a series circuit where electricity only has one path to ground. As you can see here, there are many paths to the ground. So what is the ground? How does this work? Those are the questions you're asking, and I'm going to explain that in both theory and in lab. So first of all, we have BAT1 or battery 1, and we tie it to the positive bus bar on the circuit. And I'll show you that in the lab. So we tie it to the positive bus bar, which is tied to resistor 1. And what resistor 1 does is limit the voltage in a circuit. And that's needed because certain components would explode if there's too much voltage. So it's necessary that resistors act as a speed bump to protect the circuit. So the battery is tied to the bus bar, which is tied to the circuit, and it flows up to resistor 1 and it stops the voltage. And it goes to D1, which is an LED. LED stands for light emitting diode. So like Christmas lights or anything like that? And a diode is an electrical component that forces electricity to only go one way. And this is very necessary for parallel circuits since you have multiple paths to ground. So the battery is hooked to the circuit, resistance stops some of it, the light turns on it and goes to ground, and ground is the negative bus bar. So if electricity comes in the positive bus bar, it leaves in the negative bus bar. Now let's pretend this resistor doesn't exist. The electricity would go from the battery onto the circuit, and it would make the LED explode since it can't handle that much voltage. That's why the resistor is necessary to protect the LED. Or the voltage could go to R2 and back to the ground, or R3 and back to ground. Now I'm going to make this circuit in the lab. Without further ado, let's begin. So I'm going to introduce the breadboard in the 9-volt battery and the 3 resistors and the 3 LEDs. I'm going to move the battery into place alongside the breadboard. First thing I'm going to do is I'm going to introduce my alligator clips. So you see there's a positive and negative part of the battery. We see that this right here, this whole area, this is the positive bus bar. And then we have the negative bus bar. The negative side of the battery ties into the negative side of the bus bar. Do some maneuvering. Now it's time to look at the schematic. This is a schematic. It's a map or picture of what we're supposed to be doing. And always remember this, the schematic is God. You follow it exactly and religiously, because if you make one mistake, it doesn't work. So the schematic shows us that the battery has both the positive and the ground attached to the circuit, which is what we have. Let's start with the positive. The positive goes up from the positive bus bar to the circuit. And I'm going to do that with wire. I'm going to connect the positive bus bar to the circuit with wire. Once I do that, it goes up to resistor 1. And resistor 1 is tied to an LED. I'm going to move these closer. Now resistors have two parts, an anode and a cathode. Anode is positive and cathode is negative. And electricity, as you can see in the circuit, flows from positive to negative. So we're going to put the anode first, so I have to move it into place. And then we're going to put some wire. So we're down here. So we're going to put some wire and tie it to ground, which is the negative bus bar. As you can see, we basically copy the same thing for resistor 2 and for resistor 3. So we go from the positive bus bar to the circuit, we bring in a resistor, we connect the resistor to the LED, anode to cathode, and we connect it to the negative bus bar or the ground. I'm going to make this color orange and this one yellow. And it's the same thing. We start with the positive bus bar, we bring it over, bring the LED over, resistor over, we tie it to the LED with the anode, and we tie it to the negative bus bar or ground. So when I run the simulation, they all turn on. So electricity has more than one way to go. It could go to resistor 1 and LED and the red LED to ground, or it could go to resistor 2 and the orange LED to ground, or resistor 3 and the yellow LED to ground. I meant to say orange here. And that's really all I have for you. Thank you very much. In the link of the description of this video is a link to my website. It's still new. Around a year from now, I'll update it with all my new videos and stuff, so please check that out. And please tell me how I'm doing, how could I improve, and thank you all for watching.